Hello! In today's video, we're going to be talking about the geometric transformations. We're just going to do a quick overview of what are the geometric transformations and what do you do for each one of them. So how does it influence the shape that you're dealing with? And then we're going to talk about a couple examples of each transformation. So this is just an overview. We're not actually going to be performing these transformations. We're just going to talk about what each one is. So first of all, what are the 4 common geometric transformations? Can you think of them? They are, we'll go to the next page, translations, reflections, rotations, and dilations. And there are a lot of words on this page, and I understand that. So I'm just going to summarize for you. Translation, we're taking our shape and we're moving it around. We are doing nothing to this shape other than moving it left, right, up, or down. So, say I've got a shape. In this case, I have a little astronaut, all right? So, he actually plugs into the computer and is a light. Super cute. I used to work at NASA, so I'm big into space, in case you can't tell. And now I tutor full-time. But anyways, that's a sidetrack. This little astronaut, okay, I'm going to translate him, meaning I'm going to perform a translation. I'm going to just move him. I have just moved him. That is a translation. So I was here. Now I've moved here. So I've translated this astronaut. I performed a translation. Now I could be here, and I could go up, and then this way. Or I could go down, and this way, and this way. These are all translations. Right? Just moving him. Nothing happens to this astronaut other than moving around. The next thing I have is a reflection, meaning we're going to reflect over the X or Y axis in this case, or over a line. So actually what you are seeing is a reflection or a mirror image of this astronaut. That's how cameras work, optics. You can go look at it in physics. But the next one we have is a rotation. A rotation. We're going to take this astronaut and we're going to rotate him. So in this case, he's going to change orientation if we rotate this astronaut. So we're going to take this astronaut and we're going to rotate him. He has now been rotated. Or we could turn him upside down. So we were here and we have rotated him. So his orientation has changed, but nothing else about this astronaut has changed. Now the one that would change him, and I can't actually do with this little guy, is a dilation. Dilations makes your image bigger or smaller. He's made of plastic, so he's stuck as one size. But just imagine if I dilated him, I made him bigger, I could make him a little bit taller, or I could make him a little bit shorter using dilations. Bigger or shorter. All right, so those are our 4 geometric transformations. We have translation, move left, right, up, or down. Reflection, mirror images. Rotation, rotating around. Or dilations, making them bigger or smaller. So let's go see what those look like with some general shapes. So the first one we have is a translation. Our blue is the original, our red is the new. We've taken this blue arrow and we've gone down and to the right. Or you could say I've gone right and then down. Doesn't matter. You're going to end up in the same spot. Then we have our reflection. Again, original is blue. The reflection is red. We have reflected over the x-axis and formed a mirror image of our original. Next one we have is a rotation. We've taken our blue arrow. We have rotated it about some point. And we've ended up with our red arrow. And then we have the dilation. Blue triangle was our original, and we have enlarged it. We have made that blue triangle bigger and turned it into this red triangle. Those are the 4 basic geometric transformations. If you have any questions, please feel free to subscribe to my YouTube channel for other videos where we're going to go into each of these transformations in depth. Or please go visit my website, go to the Contact Me page, send a submission, a form submission, and I am happy to answer any questions that you have.